asking us to find the equation of the tangent and the normal line. So normal line we have not talked about in a long time. We did it way back at the beginning. Does anyone remember what a normal line is? So if you have some curve, we know what a tangent line is, right? So this is the tangent line. The normal line is perpendicular to the tangent line. So if I want the equation of the tangent line, we first need a point and a slope. I've got a point. How do you get the slope? Oh, every one of you better know this answer. What's the slope of a tangent line? That's if you have 2 points, but how do I get it from this equation?
Limit of h approaching 0.
Which is also now called the derivative. So the slope of the tangent line is the derivative, which is the limit thing, but now we have our derivative rules, so we can do it other ways. So I'm going to rewrite this. X radical x. We cannot do any shortcuts when you have things multiply. However, a square root of x is like x to the 1/2. If you are multiplying those, what do you do with their exponents?
Add.
Add. So 1 plus 1/2 is 3/2. So now we could do the derivative. We learned this last week. What's the shortcut for doing this derivative?
The 2 goes in front.
The 3 over 2.
Yeah.
X, and then you subtract 1 from the power, so it's 1/2. Bo, I did not print extra notes packets, but if you have a piece of paper, you can work these along with us. I'm assuming your notes packet was in that book bag that you lost. Okay.
What? You lost a book bag?
Yeah, in Indianapolis. He left it in his room. They're mailing it, and it should be in Wednesday, they said, so.
Do you have a piece of paper?
Ben, do you have a piece of paper?
I do. How do you leave your book bag? That takes a special kind of human being.
Okay, thanks.
I'm not gonna lie.
But we are very proud of you for your success.
I was in
Bo.
a rush to get to the contest.
That's fair enough. You were distracted. Okay, so here's the equation for the derivative. So to get the slope, what am I going to plug in for my x? 1. Okay, square root of 1 is 1 times 3/2 is 3/2. So my equation, my point is 1, 1, so plug into y equals mx plus b. Subtract that over, and we get negative 1/2 for the y-intercept. So the tangent line is y equals 3/2 x minus 1/2. Now, I also asked for the normal line. The normal line is just perpendicular to the tangent line. So what would be the slope of my normal line?
2/3.
Negative 2/3. Flip it and change the sign. So plug into y equals mx plus b. So the normal line is y equals negative 2/3 x plus 5/3. All right. Is that one okay? I think I put another normal line example on it. Do we need it, or are you guys okay with the normal line? Should be fine. We've done tons of tangent lines. If you can do a tangent line, you can do your normal line. Okay, so I just want to go into some of the extensions, which those of you that were in here on Friday, I kind of told you some of these things were true without actually proving them so that you could do a few problems. But now we'll kind of spell it all out. So we're going to go through all the legal things that we can do. So if we have a constant, just like when we had limits, we could pull the constant out in front, or not, I shouldn't say constant, let me say a coefficient. Okay, so if you have a coefficient, you could pull that out in front, and a limit, you can do the same thing with a derivative. So that's a legal move. I'm going to prove some of these. I don't think I'm going to prove this one though, unless you guys really want me to. I mean, it's just from the definition of derivatives. I think I proved one for you last week on something.
Yeah, I don't really care. I mean,
I proved the constant one. So, I mean, if you guys want to see it, I can prove it. I know we did proving it like when it was an x squared, x cubed, x4. So we've done a few proofs, so I'm going to skip that. So let's just practice finding these derivatives. So you could pull this 3 out in front, or you can just kind of let it trail along. So I need 3 times, what is the derivative of x to the 4th? 4x to the 3rd. The shortcut is exponent drops down in front. Subtract 1 from the power. And so then 3 times 4 gives us 12x cubed for the derivative, without having to go through the whole limit process. Because remember, the only rules that we have so far is that if it's x to a power, we can do the derivative. So we're trying to extend that as much as we can. B, that negative, just think of it as trailing in front. What is the derivative of x? 1. You can think of this is just like x to the first, so the 1 comes down, subtract 1 from the power, and anything from 0 power is just a 1. So we just get derivative of negative x is negative 1. Okay. The next one is the sum rule. If we have the derivative of multiple things added together, you can do the derivatives of each piece separately. Another way you might see that written is f prime plus g prime. So if we have polynomials, we can do the derivative of a big polynomial just by doing each term separately. And that works whether it is added or subtracted. You can still go through and do each derivative along the way. Let's jump to an example of that. So if I want the derivative of this whole thing, do you guys think you can try it first? Alright, see if you can find the derivative, and then we'll check you. Alright, so the derivative, you get 8x to the 7th. Bring down this 5. 12 times 5 is 60x to the 4th. Minus 4 times 4 is 16x cubed. Plus 30x squared. Okay, then we get into maybe almost the hardest. This is like an exponent of 1. So when you bring that down, it's a minus 6. When you subtract 1 from the power, x to the 0 just disappears. Plus, what's the derivative of 5?
0.
0. So we can even leave that off. So that is our derivative.
I messed up mixes. Forgot one thing.
All right, is that one okay?
Yes.
Okay, if I want to know everywhere the tangent line is horizontal. Okay. Horizontal, what does that mean? Slope is 0. How do you get the slope of the tangent line? Derivative. So I'm asking you, where is the derivative 0? So find the derivative. I'm going to call that y prime equals derivative of x to the 4th
4x cubed
minus,
12x.
and the 4 would turn into a 0, so I don't need that. So I want to know when this will equal 0. What would you do to that?
Set it equals 0.
Mm-hmm. What can you do with these? Yeah, I'll take out a 4x. So if you set everything equal to 0, and 0 plus and minus the square root of 3. Could you give me order pairs if I wanted them? These are the x's. How would I get the y's? How do you get the y values here? Sub them in. Now plug them into the original, because I want to point on the original curve. So if you put in a 0, you get out 4. If I put in the square root of 3, square root of 3 squared would be 3, so we would get 9 minus 18 plus 4, so that's negative 5. If you put in a negative, when you take a negative to the 4th, it's still positive, so we're getting the same thing. So you can give me actual order pairs just by plugging them into the original. So ultimately, all these problems go back to finding a derivative. I'm just asking it a lot of different ways. Any questions on that one? The equation of motion of a particle is s equals 2t cubed minus 5t squared plus 3t plus 4. S is measured in centimeters and t is in seconds. Find the acceleration. Okay, so if we have the equation of motion, we have position. What's the derivative of position? Velocity. Then how do we get acceleration? We have to do the derivative of velocity. So, we have to do the derivative twice. The derivative of position is velocity. So what's the derivative of this thing? So acceleration would be the second derivative. So if I do the derivative of this answer, we get so that's my acceleration. And then I wanted the acceleration after 2 seconds. We plug in a 2. We get 24 minus 10, so 14. Velocity is centimeters per second, so acceleration is centimeters per second squared. Is that okay? Last bit we're going to talk about is exponential functions. We've seen e's before. We first saw them like in college algebra when we were talking about the natural log and the exponential function. E, I just told you, it's kind of like pi. It has a set number. Well, this is where it comes from. It's the number so that the limit as h approaches 0 of e to the h minus 1 over h equals 1. Okay, so that's just how that number is derived. You don't necessarily have to know that. Just know whenever we're dealing with logs or exponentials in calculus, we prefer things to be in base e for a couple of reasons. E comes up a lot when you're dealing with population, so it has a lot of applicable situations, but it's also very user-friendly when we're talking about derivatives. So when this is just talking about a few different exponential functions, they all look roughly the same, but the difference is that e to the x, when you do its derivative, it's nice. the derivative of e to the x is still e to the x. And for that reason, we prefer base e whenever possible. So we'll do a few derivatives with that, and then a couple uglier looking ones just to make sure we can handle it, and then you can work on homework. So here's my function. We're not going to compare the graphs because we would just plug them in the graphing calculator anyway. So if I want the derivative of e to the x minus x, we do term by term. What is the derivative of e to the x? Minus, what is the derivative of x? 1. That's the first derivative. Second derivative. What is the derivative of e to the x?
A constant series of c.
Exactly. And then any further derivatives we did from here, third, fourth, fifth, well,
Still just e.
they're all going to be e to the x. Yep. All right. I want to know when this graph, looking at that graph, is the tangent line parallel to the line y equals 2x. What does parallel mean?
Runs adjacent to it and everything else.
So their slopes are
It's the same.
the same. What is the slope of this one?
2.
So I'm basically asking you, when does the tangent line have a slope of 2? How do you get the slope of the tangent line?
Derivative.
Derivative. So the derivative here, derivative of e to the t is,
E to the t.
and I'm asking, when does e to the t equal 2? Okay. Who can remember? Think back to your college algebra days. If I want to cancel out that e, what do I have to add on each side?
Log.
Yes. Oh, you guys just made me so happy right there. So the natural log and the e drop out, so t is the natural log of 2. Could you give me an order pair if I asked for it? The natural log of 2 is like my x value. If I want the y, plug it in here. E to the natural log of 2. What happens when you have an e and a natural log?
Just substitute.
Uh-huh. Good. Alright. If you were in here Friday, or not Friday, Wednesday, we did a couple like the next two, but it's good practice for all of us. If I want to do some derivatives of some nastier looking functions, our derivative rules only allow us to deal with it if it's x to a power or e to the x. So I can't do the derivative of things being multiplied or divided or radicals, so we have to rewrite functions sometimes. How would you rewrite 1 over the cube root of x?
X to the negative 1/3.
Yes. I do a lot of e's on this one just for fun. So the derivative, x to the negative 1/3. So the exponent comes down. Subtract 1 from the power. Negative 1/3 minus 1. Plus, what is the derivative of e to the x? Plus, x to the e. This is still x to a power. When you have x to a power, what happens with your exponent? Comes down in front, then you have x and you subtract 1 from the power, so it's now the e minus 1 power. Okay, what's x cubed, or e cubed?
3e squared.
E is just a number. Number cubed, this is a constant. There's no x in this. There's no variable. What's the derivative of any constant? 0, so that just goes away. Trick question, you want to see that e and think of it as a variable, but it has an assigned value just like pi, so it is a constant. All right. The last one.
It's not-
It is nice and ugly. So we have to do some major reworking before we can work with that one. When you have a cube root, what do we change that to? 1/3. So I have x squared times x to the 1/3 plus x times, what if I have the square root of x cubed?
The 3/2.
Yeah. Minus, okay, square root of 2 squared is 2x squared. On the bottom, power to a power, we multiply. When you're multiplying like this, what do you do with your exponents? So 2 is like 6/3 plus 1/3 is 7/3. 1 plus 3/2 is 5/2. Okay, this is better. Is it to the point where I can work with it yet? No, because I still have a division. But I could divide each of those things. When you divide, what do you do with your exponents? Okay, so 7/3 minus 4/3 is 3/3, or just 1. 5/2 minus 4/3. So that would be like 15/6 minus 8/6. That's the 7/6. Okay, minus 2. So 2 is like 6/3 minus 4/3, so that would be x to the 2/3. Now we can finally do the derivative. So derivative of x is 1 plus exponent comes down, subtract 1 from the power, so 7/6 minus 1 is just 1/6. Minus exponent comes down, so 2 times 2/3 is 4/3. X, subtract 1, 2/3 minus 1 is -1/3. And that is my derivative. Try to get in the habit of good notation, like labeling f prime. It will be very useful as we move forward and have, second derivatives and things. Knowing where everything is located will be a big help to you. So the assignment, Friday, if you were in here, I gave you guys this part of it. So the whole thing is due tomorrow for everybody. So you have the rest